Hello everybody and welcome back to the 2005 Cayley contest. We're going to continue our look. We're almost done part B. We're getting close to it. We got question 19 and then we'll have question 20 to go, and then we'll be on to the hard questions in part C. But let's focus on what we've got to do now, and that's question 19. Okay, in the diagram, AB is 13 centimeters, DC is 20 centimeters, and AD is 5 centimeters. The length of AC to the nearest tenth of a centimeter is, and we have some options. So I'm seeing nearest tenth of a centimeter, immediately I'm feeling for my calculator. Do I have to? No, I might get lucky, but and you know, it turns out that it'll be some calculation I can make or approximate. But calculator, when they're saying to the nearest or approximately, that's the sort of thing you want, because you're likely going to have to press a few buttons and then get out some decimal expansion, and it's up to you to round it off appropriately. Okay, so I got my calculator handy as soon as I read that. So other things I'm noticing, if we take a closer look at this diagram, and I'm going to draw a picture of it, we've got some nice right angles here. And the thing that really catches my eye is ABD. We've got a 13,5 right angle triangle. So if you know your Pythagoras, if you know a lot of Pythagorean triples, you will know immediately BD is 12. Okay, let's get this this picture copied down into our notebook. Okay, so we have A, B, C is up here, and D is down here. I'm going to highlight the thing that I want in, I guess, green. We want AC. So a right angle there, and then we have a right angle up here, and we've got 20, 5, and 13. So there's sort of two approaches you can make at the start of this question, one of which is, well, I noticed that 13,5, let's fill out as much information as I can, and along the way maybe we'll get AC. Another way to try and do this is to sort of plan out, how could I get AC? You know, have that plan of attack and then calculate exactly what we need to in order to make that plan work. And they're perfectly fine. As I said, you can get 12 here. If you're uncomfortable with that, by Pythagoras, you can just say AB squared is BD squared plus AD squared. And you're not the worse for the wear. You get 13 squared is BD squared plus 5 squared. And you'll get 169 minus 25, you'll get 144 is BD squared. And you'll get BD is 12. That'd be another way to work that out. But I do try and recommend that you guys know a few Pythagorean triples, like 3, 4, 5. 5, 12, 13, 7, 24, 25. Another good one is 8, 15, 17. It doesn't come up that much, but it's a useful one because it sort of breaks the mold of having two of the sides differ by 1. Anyways, you can certainly do that. You get 12, then we got another Pythagorean triangle. We could do that as well. But suppose we wanted to get our plan of attack going first. If I want to know AC, a great way to do that, just because I'm inspired by all these right angle triangles, drop a right angle there. So extend to AD and draw a line parallel to BD through CE. We get a right angle here. So CE is going to have to be equal to whatever BD is equal to. And DE, because we're going to have a rectangle here, DE is going to be the same as BC. So AE is 5 plus BC, and you can see we have a right angle triangle ACE. We can get AC squared is CE squared plus AE squared. Okay, so this would be a fantastic way to go about doing it. And now we know CE is 12. Can we work out what DE is? Well, it's going to be the same thing as BC, and we have a right angle triangle here. 12, 20. Okay, you might notice that these are both multiples of 4. This is 4 times 3. This guy here is 4 times 5. So the remaining side, it's a 3, 4, 5 triangle. We're going to have 4 times 4, or 16 for this side. 16. Okay, well that means DE is 12, and that means AE is 5 plus 12, or sorry, 5 plus 16. I almost made a terrible calculation there. 21. Now AC squared is CE squared plus AE squared. You know, this is sort of by Pythagoras. So this whole question is really just Pythagoras, the Pythagorean theorem. So we get CE squared, that's 12 squared. AE squared, that's 21 squared. So that's 144 plus 441. We'll get 585. Now this isn't quite a square of anything, which is why we're going to have to get our calculator out. So AC is going to be the square root of 585. There's not really any squares I can see to take out here. If it were 575, we could certainly take out a factor of 25, but we got nothing like that. So we're just going to jump right to the calculator. So we get our calculator. Square root 585, 24.1. Okay, and this makes sense. The nearest square should be about 24 squared, and that's 576. So yeah, we're just a little over 24. Okay, so we get back to it. 24.18. 24.18677, and it keeps going a bit. So we want to round to the nearest tenth. This 8 means we round up, 24.2, and that should be one of our answers. It's the very first one, so it's A. So A is going to be our answer. And that does it for question 19. Join me in the next video for question 20. And as always, thank you guys for watching. If you want to, feel free to like or subscribe or any of those things. But either way, keep trying the Cayley. I'll see you guys for question 20 in the next video. Have a nice day.